Hey guys, today we're going to be working with completing the square. The main reason we have for this, I will demonstrate on the next one. So, here we have a couple of different equations. We have a standard form equation. I'm going to speed that up a little bit. This is in that ax squared plus bx plus c. And over here we have a vertex form equation. This is in a times x minus h squared plus k. So that brings us down to our vertex form, which we learned last class, and we've learned before. This makes it a lot easier to graph because this gives you your vertex. So here we have a vertex of 4, 6. So x minus h gives us an h value of 4 and k of 6. So that gives us our vertex here. Sorry, I'm trying to do some mixing and overwriting, and so it's a little out of order in some places. So we start by graphing that. We also have a negative a out in front, which means we're going to go out and down instead of out and up. So out 1, down 1, out 1, down 3, out 1, down 1, out 1, down 3, and then out 1, down 5 in both directions. So that gives us our parabola for the vertex form. What we're going to be working with today is going from this standard form, ax plus squared plus bx plus c, into factored form. To do that, we're going to do a few things. Shoot, nope, I don't like this. Hang on. All right, work in progress. The form we have here is the FOIL method. First outside, inside last, to multiply out to give us this. Next method we have is the area model method. Take that x minus 3, and we multiply each little section. There's the 3. So we multiply the x times x to get x squared, x times negative 3 to get negative 3x times x, and negative 3 times negative 3. So we end up getting x squared. Nope. In both of these, we have a double of our middle term, 5x and 5x. So x squared plus 10x plus 25, negative 3x and negative 3x to give us a negative 6x plus 9, once that all comes together. So this process brings a pattern in of twice of this, or sorry, 2 times this, and this. Run through real fast. The rest of those, they're all quick search ideas. So we have all of those. Notice that we've got some leading coefficients of 9 here. So the pattern that this brings up is 1/2 times b, that's our middle term, squared. So for example, if we take our negative 12 here, do 1/2 times negative 12, and then square that, we get negative 6, square that, and that gives us 36. That should equal, there we go, a times c. So 9 times 4, which also gives us 36, which means that this is a perfect square trinomial. So that perfect square meaning we take a binomial and square it, and when we do that, we get a perfect square trinomial. Now we're going to go the opposite direction and take our perfect square trinomials and put them in factored form. So we take half of that middle term and we put that in our factor, x plus 4, and then we square it. 4 squared should give us 16. So we continue this process. Half of our middle term gives us that number squared gives us our c value, so on and so forth. This next part we're going to be working with finding that third number, or finding that part, if we know this is a perfect square trinomial. So 5 squared is 5. So now we have one of the things I want to point out. 3, not an even number. We're still going to divide it by 2. Square 1.5 to get 2.25. Over here, x minus 4.5. Square that to get 20.25. In all of these situations, half of our middle term gives us that number squared gives us our c value. I do want you to note a couple things. Anytime this is a negative, oops, well, I'm glad I pointed that one out. That is a negative. That's a positive, that's a positive. So those signs, that -8, should match up. And let's double check my work there. Okay. So, but the third number, the c value, when we're squaring something, that's always going to come out as a positive number, because a number times itself, whether positive or negative, will always give us a positive. Now we're going to work with a trinomial that's not a perfect square. So here we have half of 16 would give us 8. 8 squared is definitely not 9. So basically what we need to do is to pretend that 9 isn't there, and we're going to do a process called completing the square to get this into a perfect square trinomial so that we can rewrite it. So, waiting for this to catch up. So the first thing that we need to do is get rid of this 9. And we're not going to really get rid of it, we're just going to kind of set it aside. There we go. So we take it away from that part, and we're just going to set it over here. Oftentimes I'll do this on a different line otherwise. There we go. So then I need to figure out what I want this third number to be. So I've got x squared minus 16x plus something to make a perfect square trinomial. What we just did was x minus 8, we take half that middle term, square it, we need that to be 64. But we can't just add 64 and do that legally. We have to add it to both sides, or what we can do is add it and then take it away. By that process, what we're doing is then, once we do that, we're going to take this 9 that was initially there, and we're going to plop it back down. So this x minus 8 squared, this is made up of the x squared minus 16x plus 64. Then I'm going to take my negative 64 plus 9, and I'm going to combine those two, which gives me negative 55. So now I have this nice vertex form, x minus 8 squared minus 55, giving me a vertex of the point 8, negative 55. So we're going to try to sum up those steps, but it's not that simple a process, and for different people it varies. So I'm just going to tell you what works for me, and that may not be exactly what works for you. So you need to think carefully about what works for you. So that whole process kind of depends on what works for you, but this is the process. Figure out what that c needs to be, add and subtract that amount, and then rewrite in factored form, that's our x minus 8 squared, and combine the remaining parts, negative 64 plus 9. Now this can be done in a lot of ways. Sometimes people prefer to like add the 64 here and then add it over here, and then eventually subtract it from the other side. So however if you find a different way that works for you, then by all means use that method. So now we have a couple of examples to go through here. So I'm going to show you kind of two different ways of going about it. I'm just waiting for there we go. So that minus 20, we kind of get rid of that, and we're just going to scooch it on over here. Going to be late for my next class. All right. So we take the minus 20 at some point. There we go. Move it over there. So then we take our half of 24, put it down here, that's our 12, square that to get plus 44, sorry, 144 minus 144, take this little section right here, that's our rewrite of x plus 12 squared, and then combine negative 144 minus 20 to get negative 164. So we have a vertex, x minus h, so this is negative 12, negative 164. Over here, another method of doing this, and I'm going too fast, is adding 4 to both sides because we don't want it. So we take this x squared minus 6x, and then we complete the square on this side. Half of 6, negative 6 is negative 3. Negative 3 squared is going to give us 9. And we also add it to this side instead of adding it to the same side. So now we have y plus 13 equals y minus 3. There we go, squared. Now we need to get that 13 back over, so we subtract it from both sides. And so our full vertex form, x minus 3 squared minus 13 gives us a vertex of 3, negative 13. So those are two different methods of doing that. Okay, now we're looking at highly proficient level when A is not 1. In this case, we have an A of 2. Or B is not even. In this case, it is, but you'll end up with some decimals. So, first off, we need to get rid of that 2. So we're going to divide everything in the equation by 2. Setting this over here, we're going to have y over 2, maybe. Well, that's one way to go. We can do that first. The other way is to subtract 11 first. So we've got y minus 11 equals 2 minus 12x. Now we can divide by 2. Either order of that would have worked, by the way. So y minus 11 over 2 equals x squared, that I had forgotten, minus 6x. Then we just complete the square with this little business. So we have half of negative 6. All that, just drop it down, kind of store it over here. So we have x minus 3 squared, half of that negative 6 gave us negative 3, square that to give us plus 9, add 9 over here, and then pretty much what we want to do, eventually, there we go, is also subtract it. So it just depends on what order you look at this. You could also have gone plus 9, minus 9, and just carried this down. Now what we need to do is unstore all this. So we've stored the 2 and the 11 over here, so we multiply both sides by 2. So on this side we got 2 times x minus 3 squared. This whole part is one bundle, so it stays the same. And then we also need, that's that part, also need to multiply the 2 by negative 9, so we get minus 18. Add 11 to get that y completely alone. So we have y equals 2 times x minus 3 squared minus 7. So we have a vertex of 3, negative 7. And then we have an A of 2. And that's that for completing the square. Hopefully this video wasn't too obnoxious and playing with some new functions, so hopefully it worked out okay. Have a good day.